Good morning to all of you. In previous session, we have seen lattice structure for realization of FIR systems or FIR filters. We also seen how to obtain the direct form filter coefficients from the lattice structure coefficients. In today's session, we will discuss how to obtain the lattice coefficients from the direct form FIR filter coefficient. Okay, so we will try to identify the values of ki's from the alphas. Okay, so conversion of direct form FIR filter coefficients to the lattice coefficients. So for obtaining this, we can use the equation in terms of am minus 1 of z is equals to, as we have seen in previous session, that we obtained the equation starting from a0 of z. a0 of z, b0 of z is equals to 0. Then we identified a1 of z, then a2 of z, and a3 of z. Okay, as in previous example that we had discussed, there were three coefficients. Okay, lattice coefficient k1, k2, k3. Therefore we identified a3 of z, right? But now in this case will be provided with maybe a3 of z, or maybe the second order, third order equation, right? And from that we can obtain, from a3 of z we can obtain a2 of z, then from a2 of z we can obtain a1 of z, from a1 of z we can obtain a0 of z, right? But a0 of z and b0 of z is 1. Okay, so we have to obtain it up to a1 of z, right? So for that purpose we'll be using this equation, that is am minus 1 of z is equals to am of z minus km bm of z upon 1 minus km square, right? Again, this bm of z will be obtained from the equation that we have used in previous session, that is bm of z is equals to z to the power minus m into am of z inverse. Okay, so same equation we'll be using to obtain the bm of z. Okay, again this will be identified recursively, right? So let's try to identify these lattice coefficients from direct form filter coefficient. So as you can see here, we are using the equation that we have obtained in previous session as a3 of z. So this is nothing but the system function given. Okay, and it has the direct form filter coefficients as alpha 3 of, this is alpha 3 of 0 is 1, alpha 3 of 1 is 13 by 24, alpha 3 of 2 is 5 by 8, while alpha 3 of 3 is 1 by 3. Okay, so these are the direct form filter coefficient. We have also seen the realization of this equation in previous session. So from these coefficients we have to obtain the lattice coefficients, as well as we have to obtain its realization structure. Okay, realization structure we have drawn in previous session itself, but again I'll draw it. So here uh, we have to obtain the three-stage lattice structure coefficient, that is k1, k2 and k3. Okay, so the given system function here is h of z, which is nothing but a3 of z is equals to 1 plus 13 by 24 z inverse plus 5 by 8 z to the power minus 2 plus 1 by 3 z to the power minus 3. Okay, so this alpha 3 of 3 is nothing but the k3 coefficient. Okay, so k3 is 1 by 3. Okay, this one, this alpha 3 of 3 is nothing but k3. So this third stage lattice coefficient is 1 by 3. Okay, so now from this a3 of z you can obtain b3 of z, okay, by using this equation of bm of z, that is z to the power minus 3 a3 of z inverse. Okay, this b3 of z is equals to z to the power minus 3. Again here we have this 1 plus 13 by 24 z plus 5 by 8 z square plus 1 by 3 z cube, right? And if you multiply it with z to the power minus 3, then you have this 1 by 3, right? Z to the power minus 3 into z cube will be 1. 1 divided by 1 by 3 will be 1 by 3. Then 5 by 8 z inverse plus 13 by 24 z to the power minus 2 plus z to the power minus 3. So z to the power minus 3 multiplied by 1 will be z to the power minus 3. This is b3 of z. So from this you can obtain a2 of z by using this equation, right? This am minus 1 of z. So a2 of z is simply a3 of z minus k3 b3 of z upon 1 minus k3 square. Okay, so if you substitute the values here, so a3 of z is 1 plus 13 by 24 z inverse plus 5 by 8 z to the power minus 2 plus 1 by 3 z to the power minus 3 minus k3. So k3 value is 1 by 3, so minus 1 by 3 multiplied by this complete equation, that is b3 of z. Okay, so it will be minus 1 by 9. Okay, so k3 is 1 by 3 multiplied by this 1 by 3, so it will be minus 1 by 9. Then again minus 5 by 24 z inverse, then minus 13 by 72 z to the power minus 2, and finally minus 1 by 3 z to the power minus 3, right, whole upon 1 minus 1 by 9, right? That is k3 is 1 by 3, so 1 by 3 square will be 1 by 9. So a2 of z, after simplification you will get 1 plus, so this 13 by 24 z inverse minus 5 by 24 z inverse, so it will be 13 minus 5 will be 8 by 24, right? It will be so similarly you can simplify it, that is 5 by z to the power minus 2, then this 1 minus 1 by 9 is there, right? So that will get cancelled, you will get 1, right? minus 1 by 9, correct? Then minus 13 by 24 z inverse and minus 5 by 24 z inverse. This will be 8 by 24, and then it will be 1 by 3, and then this again 1 minus 1 by 9 will be 8 by 9. So if you send it also, it will be 9 by 8. So basically it 3 3s are 9 will be there, so 3 by 8 z inverse will be there, right? And then again this 5 by 8 z to the power minus 2 and minus 13 by 72 z to the power minus 2. So if you simplify and again multiply it with 8 by 9 by 8, then you will get basically 1 by 2 z to the power minus 2. Okay, so again this 1 by 3 z to the power minus 3 and minus 1 by 3 z to the power minus 3, so this will be 0 simply, correct? So this is your a2 of z. From a2 of z you can obtain k2, so the value of k2 will be alpha 2 of 2, that is nothing but 1 by 2, correct? Again from this a2 of z you can obtain b2 of z, so again it will be z to the power minus 2 and a2 of z inverse, so it will be z to the power minus 2, right? Then 3 by 8 z inverse and 1 by 2 will be there, so b2 of z will be 1 by 2 plus 3 by 8 z inverse plus z to the power minus 2, correct? Again from this you can obtain a1 of z equation will be a2 a2 of z minus k2 b2 of z whole upon 1 minus k2 square, right? So this a1 of z you can write it simply as a2 of z is 1 plus 3 by 8 z inverse 1 plus 3 by 8 z inverse plus 1 by 2 z to the power minus 2, then minus the value of k2 is 1 by 2 multiplied by this, so minus 1 by 4 will be there, right? Then minus 3 by 16 z inverse, and finally minus 1 by 2 z to the power minus 2. Okay, I have multiplied the k2 with this equation. Okay, minus k2 whole upon 1 minus 1 by 4 will be there. So again if you simplify this, so this 1 minus 1 by 4, 1 minus 1 by 4 will be 1. This 3 by z inverse and this minus 3 by 16 z inverse, this will be 0, right? This 3 by z inverse and minus 3 by 16 z inverse multiplied by this 3 by 4, that is 4 by 3 will go in numerator, so 4 by 3 multiplied by this 3 by 8 z inverse minus 3 by 16 z inverse. So if you simplify it, so you will get simply 1 by 4 z inverse. Okay, so this is nothing but your a1 of z. So from a1 of z you can get the value of last coefficient, that is k1, so k1 will be this 1 by 4. Okay, so the required lattice coefficients R. So K1 is 1 by 4. K2 we have obtained as 1 by 2, and K3 is 1 by 3. Okay, and if you want to realize this lattice structure, then again x of n or x of z in input will be there. Then adder delay element, again an adder, again adder delay element, adder. Three stages you have to draw here. Right? Z inverse adder. Here it is of n or capital Y of z. Okay. Here you can indicate G3 of n, or you can leave as it is. Right. So here this K1 will be there. Right. Filter coefficient K1 will be there. That is 1 by 4 in first stage. Right. In second stage K2 will be there. That is 1 by 2. And in third stage K3 will be there. That is 1 by 3. Okay. So this is nothing but the required lattice structure and the required lattice structure coefficients. So this figure indicates lattice structure realization. Okay. So this is how you can obtain the lattice structure coefficient from the direct form filter coefficient. Right. So in next session we will discuss IR filters and their design by various method. Okay, so in next session we'll be discussing IR filter design by approximation of derivatives. So thank you for joining this session.